Okay, welcome back. This is Mr. Hassan's Maths channel, and we are now on question number 10 from the October-November 2021 paper 4 variant 2 from the Cambridge IGCSE 0580 syllabus. And this question here is about turning points, which is one of the new kind of parts of the syllabus since 2020 exam. This is something that's new. Differentiation, which wasn't in the previous specifications. So it says find the coordinates of the turning points of the graph y equals x cubed minus 12x plus 6. You must show all your working. So the turning points of a graph, basically, and this is a cubic graph, so most probably it will have this kind of shape. It's a positive x cubed, so it will have this type of shape, as we should know from our understanding. The turning points are these points over here, the places where basically the gradient is equal to 0. So for us to find the turning points, we need to know the places on the graph where the gradient is equal to 0. Now the gradient is found by finding the gradient function, which is when you differentiate this expression. So if I take this equation and I differentiate it, y equals x cubed minus 12x plus 6. So I'm going to differentiate, so I'll get dy dx equals, but I can differentiate each term separately. And when you differentiate a term, you have to multiply by the power and then subtract 1 from the power. So this is x cubed, so I'm going to multiply the coefficient of this by 3. So it's 3 times 1, which is 3. And then I subtract 1 from the power. Now when you have a x term that has a power of 1, you're kind of doing the same thing. 1 times 12, which is 12. And then you have x to the power of 0, which is equal to 1, so you're left with 12. So when you have an x term with the power of 1, basically, you just drop the x term and you're left with the coefficient. And when you have a constant, well, you differentiate a constant, it's going to give you 0. So dy dx here is equal to is 3x squared minus 12. Okay, you differentiate a constant, it becomes 0. You can think of it as, in terms of x, this would be 6x to the power 0. And you try to differentiate that, you multiply the power, it becomes 0. Or you can think about it as the line y equals 6 is going to be horizontal, so its gradient is 0. Whichever way you think about it, when you have a constant, it becomes 0. If you have an x term, the x is dropped. And when you see the powers here, you multiply by the power and subtract 1 from the power. So dy dx equals 3x squared minus 12. We know that at the turning points, we know that dy dx is equal to 0. So we have 3x squared minus 12 is equal to 0. So we can say 3x squared is equal to 12. X squared is equal to 4. Okay, so therefore x is equal to plus or minus 2. Those are the x coordinates of the turning points. We could have also solved it like this, divided both sides by 3, in which case you get x squared minus 4 equals 0. And we could have done difference of squares, x plus 2 times x minus 2 equals 0. So we end up with x equals minus 2 and x equals plus 2. Same answers, different ways of dealing with it. But then, so we need to find now the y coordinates of the turning point. So we can say when x is equal to 2, we put that back into the original equation. We're going to have y equals 2 cubed minus 12 times 2 plus 6, which is 8 minus 24 plus 6, which is 14 minus 24 is negative 10. And when x equals negative 2, you have y equals negative 2 cubed minus 12 times negative 2 plus 6. Well, that gives you negative 8 plus 24 and plus 6, which is 30 minus 8, which is 22. So the two coordinates are when x equals 2, y equals negative 10, and when x equals negative 2, y equals 22. Okay, when x equals 2, y equals negative 10. Yeah, and when x equals negative 2, you're going to have minus 8, minus 2. Yeah, that's fine. Those are the two turning points. Okay, now it says determine whether each turning point is a maximum or a minimum. Show how you decide. Now there's a couple of different ways you can decide this. Okay, there's a couple of different ways you can decide this. It doesn't say use calculus, so you don't have to stick to a particular way. One of the ways we can decide is by knowing the shape of the curve. As I said, you have y equals x cubed minus 12x plus 6. Minus 12x plus 6. So you know it has a shape like this. Okay, because it's got a positive x cubed, it's going to go up and then down, then up again. That's how we should know. So we can say as the coefficient of x cubed is greater than 0, therefore the maximum is before the minimum. The maximum is before the minimum. So we can say that minus 2 and 22 must be a maximum, and 2 and minus 10 must be a minimum, because minus 2 comes before 2, if you go along here. Alternatively, that's one way of doing it, that's fine. Alternatively, we can find the second differential, which is d squared y over dx squared, okay, which is how the gradient is changing. So you know y dy dx is 3x squared minus 12. We know that dy dx equals 3x squared minus 12. So the second differential, d squared y dx squared, is equal to 6x. 6x. So we can say when x equals negative 2, and when x equals 2, when x equals negative 2, the second differential gives us 6 times negative 2, which is minus 12. So therefore this is going to be a maximum. If the second differential works out to be negative, okay, for the value of x of the turning point, that means that's a maximum point. And if d squared y over dx squared is equal to, this is 6 times 2, which is positive 12, therefore this is going to give us a minimum. Now why is that? Why is it the second differential, when it's negative, gives us a maximum, and when it's positive, gives us a minimum? Well, we can understand that when you have a maximum, it's like this. So the gradient is changing in such a way, because when you find the second differential, d squared y dx squared, you're looking at how the gradient is changing. dy dx is about the rate of change of something. So dy dx means the rate of change of y with respect to x, and d squared y dx squared means the rate of change of the gradient with respect to x. So how is the gradient changing? It's starting off as a positive gradient, and it's becoming 0, then it's becoming negative. So here we can see the d squared y dx squared is less than 0 because it's decreasing. The gradient is starting positive, ending up negative. So the second differential is decreasing. The rate of change of the gradient is less than 0. That's why when you have a maximum, you get a negative value for d squared y dx squared. And when you have a minimum, it looks like this. We can see that the gradient is going from negative to 0 to positive. It's a negative gradient at first, ends up a positive. So d squared y dx squared is greater than 0 when you have a minimum point. Okay, so we can say here that minus 2 and 22 is a minimum, is a maximum, and we can say that 2 and negative 10 is a minimum point. And there's the answer to part B, and I think that's the whole of that question. Yep, that's question 10 done. So that's something, this is, as I said, which is quite a new part of the syllabus. Okay, now in this question, if it says use calculus to decide, okay, or to show which is a maximum or minimum, then you would have to use this method where you take the second differential. Okay, and this would work only for those graphs that you know for sure what they look like. So a cubic curve, you know that when it's got a positive x cubed, it has this shape. If it was a negative x cubed, it would be the other way around, the minimum before the maximum. Okay, if it was a coefficient of x cubed was negative. Okay, so you know, for this method here, you have to know what the curve looks like. Okay, have an idea of what it looks like to be able to decide. But for the second method here, that will work for any curve, whether you know what it looks like or not. You find the second differential and substitute the value of x into that expression. And if it's negative, it's the maximum. If it's positive, it's a minimum, for the reason that hopefully you understood when I explained that. So other questions from this particular paper can be found in the playlist that should appear in the top of the page. Other questions from this topic, which is new differentiation, can be found in the playlist that should appear in this area. You can subscribe to the channel by clicking on this link. Thank you for watching and see you soon.